Thank you, everybody, for being here. I know it's Friday afternoon and beers are outside. Going to let you enjoy that in just a moment. Thank you very much. Today I'm going to talk about on-chain metadata. Sounds really boring. It's actually slightly more exciting, so thank you very much for showing up despite the title. This comes in a couple of different things. I'll try to keep it from being too technical, but if you want to talk about the technical part, happy to stay and have a chat about that afterwards. If you're less technical and you feel it's too technical, raise your hand and I'll try to pull it back. This comes in a couple of different forms. First and foremost, when we talk about metadata on blockchains, it can mean a lot of things. It can mean anything that touches a blockchain, any transactions that have happened, anything behind those transactions. They could be events, they could be other things. Today I'm specifically going to talk about the type of stuff that you see and you care about as an end user. So first and foremost, we probably hear a lot about NFTs. Most NFTs we lovingly refer to as JPEGs. Why? Because we're pointing at a JPEG that we have a token and we point out to that thing. Generally, they tend to not be on blockchains. It goes slightly deeper than that. So, what are we going to cover today? Three things. What is on-chain metadata? I started to bleed into that, talking about NFTs specifically, but what happens outside of NFTs? On-chain metadata, as I said, lots and lots of different things. But first, let's get into what it does not mean. It doesn't mean something that's kept in IPFS or in Arweave. Great solutions, do all kinds of great things. It's not in centralized databases. They're not pointers that we keep on chain where you refer to something outside of it. And I'll come into exactly why that's super important. Oracles. Lots of people talk about how we can do something in the real world, we can save something from an oracle and bring that on chain. Great solution for a lot of things. Not what we're going to talk about today. We're also not going to talk about just saving hashes or just evidence of what's happened outside the blockchain. Hashes are great, they're verification, but they're not data themselves. Finally, get into the more technical part of things. Saving call data, saving events on chain. This is where we store what's happened in the real world. This has seen the chain, but not everybody keeps it. This is really, really important. This I call chain adjacent. If any of you have heard of Vine, loot, nouns, things like this, Dom Hoffman came up with a great framework, and he breaks on-chain into 4 different buckets. First, as I pointed out, IPFS, Arweave, great solutions, not on-chain. Things like data stored via call data. These are the things we throw into the blockchain, we save in archive nodes that nobody runs. If you run one of those, I'm sorry for you, I do the same. That's a 1-star. Yes, it touches the chain, but it's not in the chain. We also have things that we store into the chain, but you need something else for it. This is really important because although I can put lots of byte data in there, I can't really do anything with it as a user. Now the gold star, the gold standard, the 3 stars as Dom put it, is where we put everything inside and we can render it through very vanilla available things, like your browser. So things like vector data, being able to see images. If you've ever seen a loot or a noun, you don't need anything special. You just look at it, there's an image. Now you can love or hate the project, that's not the point. Everything comes out and is rendered inside of your browser. Your browser is an operating system. It's extremely important to understand how complex this thing can be and what we can pull out of a blockchain. Everybody talks about needing to take it down, do stuff off-chain. There's a lot of things that we can still push and explore on-chain, and there's a lot of good reasons why we'd want to do that thing on-chain. Let's talk about why. First and foremost, data availability. It would follow that if I can read something from on a blockchain, that data is available. If it's off-chain, it may be available. It may come from somebody else, like IPFS, Arweave. I may not be able to connect into those. Maybe if I'm in a jurisdiction where I need to go through an IPFS gateway, and they've deemed me unworthy of doing that, there are a number of countries around the world. What do? Well, just run your own node. Okay, how do I do that if I'm a non-technical person sitting in a place like Tehran? Have I done anything that's violated the law just by existing? If I can connect into a blockchain, which a lot of those people are able to do, sitting no matter where you are in the world, you know that you can get all of this information off the blockchain the same way that you're interacting through a service like I Made a Mask. And lots of these companies do specify that they're able to work inside of these jurisdictions because they fall outside of American or European regulations. Also very important, equivalence and immutability and traceability. When you put everything in a blockchain, it is the blockchain. It is as immutable as a blockchain, be it Ethereum, be it Avalanche, be it something else. That's super important because somebody can't come and turn down a handful of gateways and turn off your IPFS. They can't shut down your centralized server. You're on the blockchain. That's quite cool. Last, and this is where it gets really interesting for me, You can make it reactive. When something happens, when you have a state change, when you have a transaction, when you move something in and out of your wallet, you can change the metadata. You can change the image. It can go from red to blue if you have over a certain amount of things. Now, that's kind of trivial. But what about if you want something that's extremely rich? We talk about lots of these great things that we can do with NFTs, and we had a great presentation just now talking about things about tickets. What happens when you use it? You spend it on chain. How does that change? What happens? What happens to the image? How do people recognize that? You're doing something on the blockchain with something. Why would you not also alter that? There are a lot of gotchas, however. We're talking about blockchains. Blockchains are expensive. If anybody's used mainnet, even if you've used Avalanche C-Chain, it costs a whole lot more than using AWS, right? It costs a lot more than using IPFS. Okay. We also have to keep in mind lots of other things, like if anybody's a developer here, you've probably seen this error, call stack depth. You have too many variables in what you're trying to build. There's a lot of gotchas around how you can do it. You can worry around about it, and you can move outside of that. The other one, 0x6000. 24,576 is the number of bytes that you're allowed to save inside of a smart contract in any EVM blockchain that adheres to this. Just C-chain, most subnets, though I guess you can get outside of that, and every other major EVM chain. What this means specifically, if you're not a technical person, is we can only make our smart contracts so big. We can only save so much stuff inside of these. What that means is sometimes you need lots and lots and lots of smart contracts to do some of these really fancy things. The other one is when I read from the blockchain, when I try to turn something that's on-chain and read and understand what's going on, at some point, the person I'm reading from, if it's not my own node, will say, no, stop. You're not going to run this thing forever. Those things are gas caps. You may have heard of how much a transaction, maybe it cost 50,000, a million, whatever. You may have also heard that most large EVM blockchains cap you out at 15 or 30 million, depending on how you look at it. Generally, with something like an Alchemy or an Infura, you can read multiples of that, 500 to 600 million, which is a lot of gas, to give you an idea. We do have some really cool tools. We have things like SS Store 2. Again, if you're not a developer, what this means is we create a special smart contract that doesn't work. It doesn't do anything. It's just data. We throw it in an address, and we can read from that. That means it's essentially a floppy disk on top of a blockchain. A floppy disk on top of the blockchain. That is really cool. We can read data that doesn't do anything, but it can be read, and it can be processed by a blockchain, by somebody else that interprets it. And finally, we can talk about some of the limitations that we have that are proprietary. So again, we talk a lot about NFTs. Now, there are a couple of NFT marketplaces that we really have to pay attention to. OpenSea being one of them, Blur being another one. What do they let me do? What do they let me read? What do they not let me read? How can I build some of my contracts, some of my solutions that deal specifically with these problems and work inside their constraints? And what I'll talk about in just a moment is how we push those constraints over the history. So, liaison into NFTs. Let's talk about the evolution of on-chain metadata, and specifically within NFTs. Now, the first on-chain NFT was only kind of that. It was Avastars. No bearing in it all with Avalanche. I know we're at Avalanche Summit. It was on Ethereum. It was a very interesting project, PFP type thing. We had everything on chain, but we didn't pull it through what we call the token URI. If you ever see what your JPEG looks like, we pull it through a specific function. This didn't pull it through that. It just said, here's a copy. This is what it looks like. I'm going to describe this thing, and you can pull it up as plain text. But if somebody asks me, I'm going to send you over to a centralized server. So it's on chain, but not all the way there. Now, the first real implementation where we said, this is an NFT where there's no external dependencies. This was a project called Mandalas. Very interesting project. Personally, I think they look quite cool. This little pixelated thing in the middle. This brought everything and said, you can't call anyplace else. You read from me, and I will tell you what to present. This spoke to your browser. You could read it very, very simply. Eventually, we came into the most modern of things. If anybody's ever used Uniswap v3, if you've ever provided liquidity, you may notice that you have an NFT in your wallet. Now, that's quite cool. If you ever looked at that NFT, well, here's an image. It's even got this little animation on it, which I tried to capture. That's not the actual original image. I had to process it because PowerPoint won't take the original. Proprietary things, right? What's really cool about this one in particular is it actually reads information from the blockchain to populate what you see there. It says, what's the name of this token? Which pool did I put it in? What's the address of that token? All of these things it picks up when you first mint that. Think about that. It's reading from the blockchain to write that thing that looks like an image. It changes over time. You can destroy these, you can pick them up. It changes the tick, which is the actual price in a weird calculation. That's quite cool. We're reading from the blockchain to say, what should I show you? We move over into nouns. I mentioned nouns. This is Dom Hoffman with this cool little framework. We said, I have something that's actually quite complex. I can't just put it inside of a blockchain as it normally stands because we have things like Spurious Dragon. I can only make them so big. Let me save in information. I'm going to put a decoder so I can actually inflate. I can make this image, or this information come out and become an image that we can actually read. We're doing complex operations inside of a blockchain to render things inside of your browser that we couldn't necessarily do without lots of external stuff. This is getting really cool. This other one, you may not have heard of this one. It's called Bonsai. Personally, I love this one. This one is dead, right? Bonsais live. You can go in, hit a little function, and it waters your bonsai. It keeps it alive. Or they can die like this one. These things live over time. You can interact with them. They interact with the chain state. Very cool projects. And there's so many things like this happening. This tends to be a niche, personally one that I like. But so many things are starting to happen. We're starting to see, what can I do with a blockchain to change imagery or something else that hooks into this? NFTs are more than just a vehicle for JPEGs or something like that. Let's talk about some of the little technical standards. So everything I just showed you there is an SVG. What is an SVG? It's a vector graphic. And what this is it's very much like HTML, if you've ever touched that. It's literally words that you can almost read in English, even if you're not a programmer, that says, this is a circle. I'm going to tell you everything you need to know about that circle. Go show me that circle. Very, very simple to read. And that's generally how we start and we do most on-chain NFTs, most on-chain things. There's a couple of less common ones. HTML, visually, if you are not a programmer, they look very, very similar. They're based off of the same standard. But what we can do when we put HTML on websites, and I'm going to come more into this because this is what I think is really exciting and cutting edge, we can actually give a user a full website that came from the blockchain. You are reading a website that is passed to you from an AWS server, it's passed to you from IPFS. Why don't we do the same thing from C-Chain? Okay, that's interesting, and we'll talk about exactly why that's so important. The next thing is rasters. My little image here in the middle, this is a weird thing I made. Again, like bonsais change over time. This thing changes over time. It's a circle that you lose pixels. Now, why did I put up my own little thing in here? It's a PNG. If any of you have dealt with some of these file formats, JPEGs, PNGs, it's not something you can read. It's byte data. Remember when I was talking about nouns and inflating data? I'm going the other way here and saying, I'm going to put in something that looks like just a normal grid, pass it to my computer in a way that it can read it in a standard file format. If you've ever dealt with an on-chain NFT, one of these SVGs, you try to use it for a profile picture, like you saw my little Uniswap thing, Twitter doesn't work with it. Google Slides don't work with it. You need to go through and process it into a JPEG or a PNG or something like that. This is saying, well, let's just do that all inside the blockchain. Just give me the end image that I want and I can use that. One of the big things that people started talking about with things like SVGs is, well, it's my NFT, but it's not really my NFT because I had to process it. Let's make the blockchain do it. The last one, which I think is really cool, this is something called bleep style. Remember the first real on-chain mandalas? Same person. Put this together. Let's produce music inside of the blockchain. Let's put in actual things that produce a file that can be read by my computer, by my browser, a WAV file in this case. But what about if I want to change it over time? What if I want to read the last 100 blocks and make generative music? We can start to pull out lots of really, really cool things that deliver really cool file formats that can be composable, that can change over time based on what happens inside of the blockchain, that nobody can stop. This is just starting to broach where we can go. Let's talk about outside of NFTs. NFTs are great. I love NFTs. But there's so much more. So again, sorry, I'm showing my own thing here. I talked about how you could build HTML websites. The great thing about blockchains is nobody can stop you from doing something on the blockchain, right? The really hard thing about some of these other things like IPFS, Arweave, again, great solutions. I'm not hating on at all. They are easier to stop somebody from doing something because they're harder to keep everything you need to keep if you're a more casual user, whereas something like a MetaMask, no matter where you are in the world, relatively easy to access. Use Trust Wallet, use something like that. If I'm delivering you a blockchain through that same medium, and I'm delivering you a website, I can build a website that no one can take down without reversing blocks in a blockchain that could be millions of blocks deep. So here's a little proof of concept that I did. It is a full-fledged, very simplified down version of Uniswap. I can go in and connect that website through OpenSea, as you can see it's on OpenSea, to my wallet. It'll connect to my MetaMask and I can do a trade. Okay, Uniswap, who cares? That's pretty straightforward. What about if it's Tornado Cash? Do you remember Tornado Cash got shut down? For a long time you couldn't even get GitHub. on the Tornado Cash repos. Now I was born in the US, I no longer live in the US. I think that's a gross violation of our rights to say you can't read this information. I think we should be putting things up like websites that we are worried about being taken down and make them easy that anybody can use. Anybody can pull from anything you know how to use, like a MetaMask, like a Trust Wallet, like whatever else you want to use, and receive this information, interact with it, and you make the decision on what you can and can't do, not somebody else. Now, really cool things are starting to come out. So I put in this little tweet in here, something called EIP 4804. If you're into following EIPs. If you've ever used Brave, I don't know if any of you are Brave users, you may have noticed you can put in IPFS and a big hash, and you see it takes you to that asset. This is the same thing, but instead it takes you specifically to render a website. So somebody can put behind an ENS, you can go in and say, I want to go visit tornadocash.eth, and it'll take you to what comes outside of that ENS, which could happen to be a nice user interface for Tornado Cash. Uncensorable. Nothing over the top. When we talk about regulations, everybody's starting to talk about front ends because it's hosted by somebody. Well, what if the blockchain itself is hosting your website? How do you stop that? You can't. What about if we put entire file systems inside of it? This is something called ETHFS. This is a way to use SSStore2, as I was talking about, to save entire libraries inside of it. My little website that I talked about in the beginning, we saved ethers.js. If you're familiar with that, that's the way to tell MetaMask how to interact with the blockchain outside of the chain. That means even if you're in a place like Tehran, they can't even shut that down from your CDN. There's no way that they can stop you from interacting with the blockchain, no matter where you are in the world, as long as you have an internet connection and a JSON RPC provider or a node that can connect to it. We can make things much more robust. I work in JPEGs. I love JPEGs. A lot of what we talk about with Web3, we've lost the reason we're here. We've lost the censorship resistance. We lost fighting against people trying to stop us from transacting. I believe it's a fundamental right, and these are things that I think are very exciting and where we can go ultimately with using on-chain metadata inside of NFTs, outside of NFTs. There's so much more to do, and we're very, very much just scraping the surface. Let's talk a little bit more about this. Everybody who's spent any time developing anything on a blockchain, and I talked about how small these things need to be, they're going to say, yeah, okay, you're just going to save tons and tons of stuff on a blockchain. Great, but again, that's going to create new headaches. Some of it we can mutualize, things like ethers.js. We don't need to update all the time. Not everybody needs to redeploy. It does cost a lot of money. One of the nice things about doing this is, well, I can just deploy that into a subnet or a seed chain or some place that somebody can access, and I can still use that website to interact with Ether mainnet or Arbitrum or anything else that's EVM. Hell, I could even build a Bitcoin wallet that's delivered through seed chain. Okay, that's quite cool. I can use less expensive chains to save some of this information, which are still robust. But we can do one other optimization. We can do something, if you've ever spent any time with like GraphQL, things that like resolvers. What this means is instead of writing everything, a full-fledged website, we can put together libraries that explain how to write a website very efficiently in Solidity. So it's an API to write Solidity, a bit like how React writes HTML with JavaScript. We're just using Solidity to do the same thing, which means it's much more compact, and you can come up and you pull things only as you need them when you read them, and in certain places, in a language that, if you're a front-end developer, probably hates Solidity. If you're working with this, it's much more ergonomic to write these types of things. Makes everything much more efficient, but on top of that, it can change over time. If I want to upgrade my website and it's a smart contract, well, I can instruct it how to upgrade itself. I can add these things in. I can send somebody a new website. I can just create new issues as we go, as we fix things, as we improve things, in a much more efficient way than if I was just to dump a full, flat website. Again, we're just starting to scratch the surface with this. I think my way of looking at the world, and I've been in crypto since 2013, 2017, ICO boom, became 2020, DeFi. 2021, PFP trading, JPEGs, is going to become, I'm optimistic, 2024, something with NFTs, using metadata, specifically pumped through NFTs or through other aspects to create new things that are not pure speculative token uses. They're building value to somebody else. They're building something that cannot be built through traditional web technology. We're not talking about bridging Web 3 and Web 2. We're talking about using Web 3 the way that Web 3 should be used. So with that, thank you very much. I see I have about 40 seconds, and then I know that I am the last person to talk here. But if there are any questions, happy to take them now. Otherwise, after this, happy to have a chat.
So you mentioned storing
You can split them over things, and there's a number of different ways we can pull together multiple addresses to pull together multiple files. Again, there are limits, 500 million gas being kind of one of the hard limits at this point. Generally, if you strip down a lot of the images outside of a website, that Uniswap one I put together was 5 kilobytes, and it interacts with Uniswap. 5 kilobytes to interact with Uniswap. We're not talking about needing to have amazing branding on top of these things. We're talking about people being able to access these from their homes in Toronto. We're looking for just what's the basic. Yes, you can make them pretty. Yes, you can make them instructive and easy to use. But you're not going to try to build a full React website with lots of features and imagery and put videos on it. Now, you can put more complex things on there, but you wouldn't necessarily access them in exactly the same way. So you do live with those constraints. Is there a question over here? Yeah, so there's two types of functions inside of an EVM, any EVM blockchain. The first is a transacting function, a call, and the second is called a static call. Much like you can imagine, it doesn't actually do anything. It's like writing something in a book and just reading from that book. Reading from the book is quote unquote free. There's no transaction charge when something's read into it. Token URI, when I read where an image is one. The other one we probably see a lot is what's the balance of a particular token in my wallet. Now that's a very, very small function. But what you're able to do essentially when you're only reading, you can make them unlimitedly large if you have access to your own node. You can do very, very complex full computer sets of operations that would be well beyond what anybody would let you to do. What we try to limit ourselves, as I said, 500 million gas, because that's generally what Alchemy or Infura would stop us out at. So with that, we're still able to produce very complex things. My little circles there, that's producing a full PNG file that was 128 by 128, which is not massive. But if you consider that inside of a blockchain, that's quite large. Great. I think that's my time. Thank you very much for coming to the last talk of the end.